So in problem 12, we're supposed to find several things. First of all, let's just do it right straight up. First of all, we're supposed to find f of 0. So what's the function value right at the origin? So if we just put 0 right directly into the function, we're going to get, well, 3 times 0, what do we get? 2 over negative 1? We end up with negative 2. So f of 0 is negative 2. There's 1 of what we're looking for. Now we also want the derivative at 1. So first of all, we better get ourselves the derivative. So I come back up here to this function. It's a quotient. So I'm going to use the quotient rule, and I like to plot it out by writing the template, the bottom times the derivative of the top, minus the top times the derivative of the bottom, over the bottom squared. So f prime of x is, okay, we got the bottom, quantity x minus 1, times the derivative of the top, which is a 3, minus the top, which is that 3x plus 2, times the derivative of the bottom, which is a 1. Do you believe it? You've got the x, so the coefficient of x is just 1. Derivative of x is 1. We get a 0 here. All right, and now the bottom squared. So this is that x minus 1 squared. Let's multiply it out in the top. So we'll get 3x minus 3, and then multiplying by negative 1, we'll get minus 3x minus 2 over x minus 1 squared, and you know those 3x's will go out. So we are left with this for a derivative. F prime of x is, looks like negative 5 over x minus 1 squared. There's our derivative, but we really want the derivative at 0. So what is f prime of 0? So we're going to get negative 5 over 0 minus 1 squared. I think this is just negative 5. So f prime of 0 is negative 5. Now what about the second derivative here? F double prime of x is, all right, so go back to the first derivative. Here's our first derivative way down here, all right? So what I'm going to do here is, since I have a quantity to the second power, I'm just going to bring this second power up. Now you could use the quotient rule if you want, but I'm going to rewrite this like this. I'm going to write it, you know what, I'll write it right here. Let's go with this color here. So we're going to go f prime of x is negative 5 over that x minus 1 squared, but I'm going to write that as negative 5 x minus 1 to the negative 2. This way I can just use the power rule instead of that quotient rule. I don't know if that was a good color. Well, anyway, here we go. Here we go. So to differentiate it, bring the exponent down as a multiplier. So negative 2 times negative 5 is 10, up here, 10. And then we get the x minus 1 to the negative 2 minus 1 is negative 3. So how about if we write f double prime of x as 10 over x minus 1 to the positive 3. There's our second derivative, and we want it at 0. So f double prime of 0 is 10 over, now if you put a 0 in here, you get 10 over negative 1 cubed, which is negative 10. All right, so we got the first derivative way down here being negative 5, and we've got the second derivative here at negative 10. So let's answer a question here. So the question is, what's the slope of the tangent line at 2? Well, that takes us down to the first derivative, right? First derivative gives us the slope of the tangent line, and at 0, oh, wait, do we want this at 0? Oh, we want it at 2. So I got to go back and do this again now. You know, I just have a feeling well, that's okay. At x equals 2. So let's go back and put 2 into the first derivative. So if we do this, what is f prime of 2? We'll get negative 5 over 2 minus 1 squared. That's negative 5 over 1 squared. So how about negative 5? So the slope of the tangent line at x equals 2 turns out to be negative 5. So I'll put that negative 5 back up in here. Is negative 5, which is interesting, isn't it? Because if you look down here, what's the slope of the tangent line at 0? It's also negative 5. So at 0, the slope's negative 5, line is going down, and over here at 2, it's negative 5, it's going down. Interesting. Okay. And now we're asked for the value for which f of x itself, not a derivative, but just f itself is 0. So here's f. It's 3x plus 2 over x minus 1 equals 0. So we need to solve this. Now this is a fraction. The only way a fraction can be 0 is if the top is 0. Bottom can't be 0. If the top is 0, right, 0 divided by non-0 is 0. So the only way this can be 0 is if 3x plus 2 is 0. So 3x is negative 2, or x is negative 2/3. So to answer this last question here, what's value of x is going to give us f of x is 0? Negative 2/3. So this curve up here, our original function, crosses the x-axis here at negative 2/3.